Hi, everyone, wherever you're listening from. Welcome to API 2021 Specification Conference. The theme of our talk is the ABC of GraphQL. So here we'll be walking you through the ABC of GraphQL, what GraphQL is, the do's and don'ts, and how to go about making your first GraphQL API. So my name is Alabi. I'm a front-end engineer at TechDigi, Lagos, Nigeria. At TechDigi, I am responsible for integrating of internal and external third-party API, and I ensure that users, they have awesome experience using the app. And also, I implement design of mobile websites. I optimize the user experience. I develop and maintain the user interface. I create tools that improve site interactions regardless of the browser.
Hi, my name is Olanrewaju Sule-Balogun. I'm a backend engineer at Seamless HR. I'm responsible for creating the structure of server-side information, write business logic, server script, API that eventually be utilized by front-end engineers. I build and integrate with APIs. I also generate reusable code libraries for our human resource activities.
Here is our agenda for today. We're looking at the introduction to GraphQL. We're looking at why GraphQL, the concept of GraphQL, and why do we need to how to connect our GitHub GraphQL API, how to make your first GraphQL query with GitHub GraphQL API and Postman. The community is backing GraphQL as well, the resources used, question and answers.
So what are some of the learning objectives to take away from this talk? We are going to learn more about GraphQL, have basic understanding of some of the GraphQL concepts. We're also going to be able to know how to generate personal tokens and define scopes with GitHub. We're also going to get familiar with Postman, what Postman is about, and also how to make requests using Postman. We are going to be able to query GraphQL API with Postman.
So let's go proper. Introduction to GraphQL. So what is GraphQL? GraphQL is a querying language. It describes how a client should request data from an API. It's a standard for a well-written structured data queries, as it lets you describe data, makes you ask for what you want, and it gives the expected result. So there's an article written by us on how GraphQL works, introduction to GraphQL, and how to make your first GraphQL API.
Here we are going to try to paint a scenario using REST and GraphQL. On the left-hand side is a REST query that allows us to fetch all users, fetch users by post, and also fetch users by ID. You'll notice here that we are trying to make 3 requests to different endpoints. On the right-hand side here is a request being replicated using GraphQL. With GraphQL now, we ensure that we are only trying to make a request to just one endpoint, and here we have our queries. Queries allow us to make requests to the server. The queries here will now be what we are going to try to modify when we try to request these resources from this endpoint. On the first box here, we are going to be making queries to fetch all users with field ID, name, and email in our response body. The second query here is still the same endpoint, but here we are going to try to modify our queries. Since GraphQL is a query language, we will always keep modifying queries to request for what we want. In this second scenario here, we are fetching all users with ID and name with attributed post title. And on the third part here, we are still making use of this single request URL and also defining our queries again. This time around, we are defining our queries to accept an argument, which is an ID of 1, to get the first user with ID, name, and email on the response body.
Why GraphQL? So why do we use GraphQL? Why do we need GraphQL? GraphQL helps in describing your data. GraphQL provides declarative, efficient data fetching. It describes data. GraphQL is a strictly typed schema. It supports strictly typed schema in the sense that information you provide has to be strictly typed. Project as seen here, it is a graph field object, which means that the type with some fields, we have string, we have tagline. The tagline here is a string. The name here is a string. And we also have contributors, which is an array of users. So here we just described how we want our data to be schematically, strongly typed schema. The second box shows that we are asking for information. So here, we are querying projects. We passed in an argument of name that has a string of GraphQL to give the property of tagline. So here we are requesting for the property of tagline from the argument of GraphQL, querying projects. The third box shows that we are getting our results we predicted. Here, after querying projects, we get the result tagline, that's a string that shows a query language for APIs. So exactly what we requested for was what was gotten.
Here, what are some of the problems? What are some of the problems GraphQL help us solve? One, no overfetching or underfetching. What do we mean by this? Since GraphQL help us define the structure and names of what we are querying for, it also ensures that we are not able to query for more than what we don't want, and we can always specifically itemize what we want from our query. Strongly typed schema. From the previous slide here, you can see on the type object here of project what the type intent looks like, to be name, to be typed to string. So since we can specifically type what we want, GraphQL also ensures that it is a strongly typed schematic language. Insightful analytics on the backend. With insightful analytics on the backend here, we are able to depict what API responses are more queried for, and we can then further be able to optimize such responses, and also we can be able to generate analytics for such responses to also ensure future improvement on such endpoints. Also, faster time taken to resolve requests. Since we are always making requests to one single endpoint and users are able to declare what they want, it also means that there is little overhead as to the time taken for requests to get resolved using GraphQL.
The concept of GraphQL, we have several concepts of GraphQL. So here we'll be looking at the one query. What does query do? Query is a way of requesting data from GraphQL server. So here we have books. We are querying books. We pass in an argument of name, roses are red. So it means we want to get author, name, and genre from the argument passed. Roses are red. So every information gotten from here will be from the argument passed. It has to relate to the argument passed in. We already filtered the information we want to get. So the information we're getting information from the book Roses Are Red. And from the book Roses Are Red, we are getting the author, we are getting the name, we are getting the genre, as seen in the response box. The book we queried in the response box, we have an array of our response. So if we have array of strings here, author, that gives James Patterson, the name, Roses Are Red, the genre, crime, thriller.
Here's another concept of GraphQL, which is a schema. Schema is a representation of object type. It represents the kind of object you fetch from your server or your service and what field it has. So here is the type name book, which is an object, and the items on this object are the names of the fields we want the object to have. So here it means that a book has an ID, a book has a name, a book has an author, a book has a genre, a book has a code, and a book also has a sold out value. Here, this ID here simply ensures that it is non-human readable, that we can use to uniquely identify which book we are looking for when we try to fetch. Also, you notice we have some exclamation mark here. The exclamation mark here simply notifies us that this type of fields are not nullable. So when a request is coming, we want to ensure that it has a value. So we don't want to make it nullable. Also, this linear here is an array of non-nullable objects. It's of non-nullable arrays. So it means that here we can only accept an empty array or an array of values. So the genre can now come in form of a comedy book, a thriller book, an action-packed book, a romantic book. Also here, the code here we are accepting here is an integer. So because it's an integer now, we are not necessarily making it a required field, so it can be nullable. The Boolean here is also to show that, okay, a book can actually be sold out or still be available, which we can now identify with a true or false value. Here on the right-hand side here, we have the schema types, the scalar types. So what are scalar types? Scalar types are what these schemas resolve into. So when we make a request body, these are the expected default values we can only get from a request. So it can either be an integer, it can be a floating point number, it can be a string, it can be a boolean, and it can be an ID. All these scalar types here will now be uniquely used to map our data with our response when we get them.
So the third concept of GraphQL we'll be looking at here is mutation. Mutation is also a query language, but what makes it different is we don't use query here, we use mutation. Mutation supports the modification of our request. Mutation enables us to modify data on the server side. The modification includes we can create data, we can delete data, and we can update. So here we are creating a book data. We pass in title, author, page, ISBN as an argument. So we are creating a book that should carry this argument. As seen, as the property shown, title, author, page, ISBN. At the response box, we can see that the create book returned an object. We have title, we have author, we have page with an integer, we have ISBN here, which is a string. So here now we got exactly book we created. The information passed in as an argument, we got the exact response.
Another concept we are going to be looking at are resolvers. So what are resolvers? Resolvers are query handlers for our GraphQL. So they basically help us handle our queries. So to define a resolver accepts four arguments, which are the root, the argument, the context, and the info. And then we try to get a result from it. Here we are trying to paint a scenario of how a resolver is being used. On the first box here, we are trying to define a schema to the name type of user, and we also have fields on this user schema. So the IDs are IDs, the full name to be a string, email to be a string, and the age to be an integer. Now on the second box here, we are trying to resolve the request. So the request we are trying to resolve will be for root and argument. So yeah, what the resolver basically do is that they help us return all users. The third box here is a post request you are making from whatever service you are making use of. So here we are trying to use all users with ID, full name, and email. And here we are also trying to get a return response with a user object of the particular users we have. So here, what basically the resolvers will help us do is that they help us define your business logic inside of your resolvers here. So all your logics that you want to do, you want to filter, you want to fetch all, you want to create, all those logic here comes within the resolver. And to replicate it, you need to define a schema, define your resolver, you make your request, and then you get your data.
So how to connect to GitHub GraphQL API demo 1. So I'll be walking you through how to connect to GitHub GraphQL API. So first, you need to generate a GitHub token. I'll walk you through how to generate a GitHub token. So first, go to settings. From the settings, you go to developer settings. From developer settings, you click on the personal access token. For your personal access token, you go to generate your new token. So it prompts you to put a name you want to save it with. And after the name, we have expiration. So here, I'll be using generate developers access token to save my GitHub token. So I want it to expire in 7 days. So we have scopes. These scopes just make you have access to some, maybe you want to have access to repo. If you tick repo, it means you have access to repo. If you select workflow, it means you want to have access to workflow. So for here, which is selecting repo, we're selecting admin org, we're selecting user. Then you click on our generate token. Yeah, so copy your token because you make use of your token in the Postman environment. So that's our playground.
Here is what Postman looks like. with Postman, you have collections, you have APIs, you have environment, you have mock servers, you have monitors. You have a whole lot of workspaces you can work with, and this is where we are going to be making our request. So with Postman here, we are going to come to authorization to have access to our tokens and set our tokens. Here we are going to select bearer tokens, which is also a type of token. Here we can either copy and paste the token we generated here, or we pass it in as an environment variable. So here you define the environment variables, and here you are able to set what the environment variables look like. Here I've gone on to copy and paste a token ahead, and here I can make use of it globally as a variable. So here I can also come here and select the HTTP verb I'm going to use for this request. So for the endpoint we are working with now, we are going to be making use of a post request. With post request here, we can now come here to define the GraphQL endpoint, which is this URL, and it can be found on GitHub GraphQL Explorer. Here we can also come here to define what our body of our request will now look like.
So here the body of our request, so we're taking GraphQL option. So we want to make our first query. So I'll walk you through how to make your first query here. So you type your query. So here we'll be querying a GitHub username. So the user, then the parentheses, login, and the GitHub username we want to query. So here I'll be querying Palumi codes. That's the GitHub username. So what do we want to get from Palumi codes? We want to get the person's name. You get the name, you get the email, we get the avatar URL, you get the file. So you're making 5 requests to the GraphQL server. Name, email, URL, avatar URL, and the file. Then we click on the send button. So as you can see that a successful response has just been sent. So here we now have access to Palumi codes, GitHub username that we queried, her name, the email, the URL, the avatar URL, and the bio. So let's confirm what we got. So let's check through, let's see, the URL. Let's copy and paste that, paste the link in the browser to confirm if we get the exact response. So as you can see now, so we can see the URL took us here. We can see the picture of the person, the bio of the person, where the person works. We can see overview repository. So let's check. Let's check the person avatar's URL. Let's check the result we're going to get. As you can see, the avatar URL brought us here. So we now have access to the person's picture. So as said before, the GraphQL, when you search, when you query, it gives the exact response that you queried for. So also the bio, let's confirm the bio. Is it the exact thing? Yes, it is. And highly focused and multifaceted young front-end developer was this. Okay, so yeah, so here is how to make your first GraphQL. So here is an easy request to the GraphQL server. So let's look at making a complex GraphQL server, GraphQL request.
So here we are going to be making a much more complex GraphQL request. And here what we are trying to do is we are trying to replicate what this repository structure looks like. So here we can now say we want to make a request with another username, which is Lariso. Here we are going to try to request for lots more detailed information about this particular user on GitHub that include the name, the URL, the Twitter username, the avatar URL, email, bio, the followers, who are total number of people following, who are total number of people who are following the person, the total number of card repositories. Does this person belongs to any organization? If yes, return the first 5. What are some of the recent repositories that this user has? we are trying to request for the last one. You can also notice here we can query by different type of direction. We are querying here by the created at field. We are also making sure that this is returning in a descending order to give us the recent 5. We are also trying to give an affiliations to be an array of owner. So we want to know the project this particular person has created himself. So here we are also going to be returning the total count. Here we are going to be returning the nodes, which is an object. So the nodes will now replicate the name, the URL, what type of primary language is this particular repository written in, is there any total number of forks, the updated art, and the start result count. Here we are going to now try to click on the send button to have access to the response. As you can see here, it's a successful response again with status 200, which Postman already defines for us. Here we can view the response in different forms. We can either click on pretty, raw, preview, whatever. So here we can now come here to view what we get in our response here. So we have the name, we have the URL of the person, we have the avatar URL as we have shown earlier, we have basic things. Also here we have the followers to be 25, the following to be 48, the total count to be 34, where we are now going to confirm if this data actually is consistent with what GitHub is telling us to be. So here we're going to have an overview of the repo itself. So we can also confirm this is 25, this is 48 and 34, as you have also seen here. We'll also head over to the repository section here, where we can also see the recent 5 project this person has actually created himself. This is a particular project, this is another project. So we can now head over to Postman to also see the languages these projects are written in. So for some, you see it is primary languages in JavaScript, some are in JavaScript, while others are probably in PHP, like this Happy Socks. So this is how you make a request with Postman. And ahead of this talk, we've also gone ahead to create a documentation for the audience to walk away with and also be able to practice with. So this is the official documentation which has been published here, and you can have access to the URL here, which can be found here. We have the request type here to be posted here, and these are examples sample data which we have added here. Authorization requires a token which can be defined. Also, the much more complex one here can also be found here with the sample data which we have also created for learning purpose here as well.
So we have communities backing GraphQL. We have several communities backing GraphQL, as you can see, as listed here. And also below, we have URL that takes us to several communities backing GraphQL. So you can also check that out to have access to more communities backing GraphQL.
So what are some of the public workspaces resources we have here for you guys? So here we have the official GraphQL documentation that explains what GraphQL is about in a lot more details. Here is also a tutorial, the GraphQL documentation. Here is an overview of an article that walks you through the ABC of GraphQL in much more detailed explanation, which can be found here, where we talk about a whole lot of concepts which we have been emphasizing on during the talk. So you can have the overview of it here of Code Camp. Here we also have the Postman documentation as well that teaches how to query with GraphQL. We also have the GraphQL documentation as well here, which is very, very much detailed as to what GraphQL is about and how you can actually work with GraphQL. So here we're going to be having a Q&A session where you're going to be asking questions and concerns, and we'll be able to try as much as possible to follow up with answers that would help guide your learning.
Thank you for your time. If you need to have more conversation, feel free to continue the conversation with us. Connecting to our Twitter handle at Alabi_, and at Dev Larry.
Thank you very much. It's such an exciting time. I hope you had fun as much as we have had. And thank you for the opportunity given to us.